Welcome back to MDriven. We're gonna watch another video of another architect. If you remember, I did a reaction video to Randy Shoup as he walked through UML and what it was used for historically. And I got a little bit frustrated that he only seemed to talk about how to use it for the external subsystems of system components and how they should interact with each other, when we at MDriven are totally focused at the internals of a system. And that is where we at MDriven think that the main effort of problem solving should be put. And listening to this architect, Randy Shoup, we will get some reflections, and I will stop and point out what I think is important in what he says. So let's watch it.
Great, thanks Bronwyn, that's really great. All right, yeah, so I'm Randy Shoup, and I want to talk to you today about minimal viable architecture. So thematically, very similar to the talk in this room just a moment ago, there's really no one perfect architecture for all scales, for all phases of evolution, and for all problem domains. This is pretty obvious, but I think sometimes we have a little bit of envy of other people's architectures and try to think that we should do them when we should really be solving our own problems. So the kind of structure of this talk is about, let's talk about the different phases of companies and products. And I think all products kind of go through this S-curve, and we're going to notice that there are different architectures that are appropriate at different levels.
So the first thumbs up is on what is said, that there is no one architecture, and that's obvious. And one should focus on one's own problem and not trying to mimic the perfect architecture from somewhere, because it doesn't exist.
Different scales of the company. So a little bit about my background. So most recently, I was VP of Engineering and Chief Architect at eBay. I also spent a bunch of time at eBay as an individual contributor earlier in my career. I've been a engineering director at Google for Google Apps. And Amazon started their kind of inexorable takeover of the world's online retail. So architecture really matters. Okay, so what can we learn from these two stories? The first one is that no one starts with microservices, but past a certain scale, everyone at these large scales ends up with something that we would call microservices. But the other point I think here is that most never reach that scale.
So, very good points. No one starts with microservices. Why? Well, it adds complexity. And you would only want to add complexity if there is a real purpose that you want to address. And this is very important, that you don't start to address purposes that you don't have and that you haven't seen. Because you can't guess the future. You think you can guess it, but you can't.
So it's pretty important for us to understand what the problem that we're currently solving at our company, as opposed to envy of the larger places. The other way I like to say it is, if you don't end up regretting your early technology decisions, you probably over-engineered. There may well have been another company that were in 1995 that was could have been an eBay and Amazon competitor, that instead of building a monolith and solving customer problems, instead they built a distributed system. And there's a reason why we've never heard of that company.
Yeah. So what it says here is that if you overdo it initially, you never get the experience to do it right. Because if you never reach the market, you don't get the information. If you don't get the information about what that market actually wants, you're gonna solve the wrong thing anyway. So it's important to get out there quickly to actually learn from real cases.
Okay. The structure from the talk going forward is I want to talk about the phases of products and companies, and then talk about what are the appropriate kind of patterns and forces at each of those things, which will tell us what kind of architecture we need to have. So let's start with what I like to call the idea phase. So this is before we've written any code. What is the thing that we're even trying to build? And if you take nothing away from this talk, I guess I would ask you to take away these 7 words because they're so powerful. What problem are we trying to solve? So this is the question that we're asking ourselves at this idea phase. What's the problem that we're trying to solve? Is somebody willing to pay us money for it? Is there product market fit for the solution that we think we might want to do? And why is this so important? I'll just lean on Mary and Tom Popendick in their excellent book, Lean Software Development, because building the wrong thing is the biggest waste in software development. So we really need to understand our problem in order to avoid building the wrong thing. The other quote that I like on this line is from Charles Kettering, who used to be the head of research at GM. A problem well stated is a problem half solved. So if we can be very clear on our problem, we're well along our way.
Very good. So a problem well stated is a problem half solved. Back to MDriven. A problem well stated. That's what a model is. If you're able to state your problem in a model, it's well stated and half solved. If you have MDriven as a deployment mechanism, it's more than half solved.
Okay, so at this idea phase, the way I would suggest that we look at architecture is everything is a prototype, right? So our goal here is to explore the potential problem space that we have as rapidly and as cheaply as possible. We want to find a business model, we want to find product market fit, and we want to acquire our first customers.
Yeah. So he stresses the ability to be able to be fast. And I totally agree. And the idea to start with a complex architecture is, of course, ridiculous. No one in their right mind should do that. You should investigate what the solution looks like in this phase. And arguably, we might differ a bit here, you should continue to have that mindset that what kind of problem are you trying to solve? That's not something you only ask during idea phase. You ask it continuously over the whole life cycle of your development, because it's not one problem. It's a multi-headed problem, and it's going to split into what you first thought was one problem to be hundreds of small or at least smaller problems.
And so the goal here is rapid iteration. So everything that we build here is going to be a prototype, and we're definitely going to throw it all away.
So definitely going to throw it all away is wrong, because if you state your problem in a very well good manner, it's half solved, as he said. But why would you then want to throw it away? So this mindset comes from the idea that has percolated in the developer community about quick and dirty. Quick and dirty is something that we use, but we don't intend to build upon because the technical depth is way too high. I agree. Quick and dirty you shouldn't keep. Quick and clean, that's something else. That's what MDriven does. Quick and clean. You might very well end up with models that you throw away in MDriven. And because you have tested them on customers and you see that this is not the problem that we should solve. And then you throw them away. But if it is the problem that you're trying to solve, then you should continue to build on it, because the solution is actually the cleanest it can be with a model. It's no technical depth at all on model stage. So that's important.
Whether we think we're going to do that or not. So ideally, we have no technology at all, right? So there's a reason why users...
And again, ideally, we have no technology at all. That is only ideal if paper lets you compile, deploy, and put it in hands of real users so that you can get real feedback. because it's the hardest thing of all to get a user to imagine that this actually works and you were to push this button, what would you like to happen?
Experienced designers use paper prototypes. That's because we can rapidly look at potential ideas and literally throw them away if they're not good ones. So the way I like to think about it is engineering is about solving problems, and only sometimes do we solve those problems by writing code.
Good point. Solving problems is done by understanding needs. Understanding needs forces us to be able to articulate the problem and the need. And a great way to ensure that we are actually articulating all the aspects of the problem is to do a model of it in MDriven and press play and see that all the needs are covered by the use cases that you offer. To just roll the problem down the hill and see what breaks. And if that is truly cheap, then that's the thing that you should do.
So we talked about the idea phase. Now I want to talk about what I'll call the starting phase and what characterizes the starting phase, so that we have one team. So maybe we're 5 people. We all fit around a conference table, and we have a pretty short time horizon, right? So we don't necessarily know that we're going to exist 1 year, 2 year, 5 years down the road. So we definitely shouldn't be building technology in order to solve problems that we only are going to have 1 year and 2 years and 5 years in the future. So the kind of architecture that we want to have in this phase is what I'll call just enough architecture. So we want to meet our near-term evolving customer needs as cheaply and as simply as possible. We want to delight those first customers that we've hopefully acquired, and we want to acquire more. So here, the goal here is for us to do rapid learning and improvement. We want to prioritize team productivity over really any other thing, and this is definitely not about scaling, right? So this initial phase.
Yeah, I agree. This is how you should, the mindset you should have all the time. And the last point, not about scaling, maybe, yeah, you should have that mindset as well, all the time, not only in the startup phase, because it's not about scaling your architecture. You only do that when you run into some specific bottleneck. And once you do, the solution might very well be that you haven't learned all the ifs and buts of the information you handle, rather than spinning out and dividing everything across microservices.
Is not about scaling very large, because we're not large yet. So one of the quotes that I like in this area is from Martin Fowler. So the best code we can write now is code that we'll probably discard in a couple of years' time. So what would just enough architecture look like in this starting phase? So we want to use simple and familiar technology that's familiar to the development team that we have. We want to prioritize expressive power and ease of use for the developers.
Yeah, and this is where MDriven fits in, of course, as well. So expressive power and ease of use, and the rapid prototyping frameworks. Of course, rapid prototyping frameworks often have these glass ceilings that you can reach this level, but you can't go beyond. And that's not the case with MDriven. So that's important to know, that there's always a way forward once you're based on MDriven.
And this is why a lot of the startups that ultimately become successful start with these kind of rapid prototyping frameworks like PHP or Ruby on Rails or something like that. And that's because it doesn't optimize for where we end up later necessarily, but it does optimize for our ability to prototype very, very quickly. And so here's where we think the monolithic architecture is appropriate. And this is the previous talked about how they started in a monolith, and I would recommend everybody do the same. So single application, single database, and basically no infrastructure, right? So What we want to do here is ideally something kind of like platform as a service, where we build that monolith on top of that. So the architecture diagram, such as it is, and apologies to Simon Brown in the room, it's super simple. Like it's, you know, we shouldn't try to get too fancy because our problem statement isn't too fancy yet. So what are, you know, all of engineering is about trade-offs, and so what are the trade-offs that we have right here? So there are some good things about a monolithic architecture, even though it's, you know, a slur a lot of the time. So it's simple at first, right? Anytime we're communicating with different parts of the system, the latencies are in process, so you know, everything is a lot faster than it would be if there were a network involved. It's typically a single build and a single deployment unit. That's almost the definition of a monolith. And then it's pretty resource efficient at small scale, actually. But of course, there are a bunch of cons, right? So as our team grows, the coordination overhead of being in the same monolith, you know, grows.
This is interesting. It takes one of the cons with the monolithic architecture, or the clean architecture, the initial architecture, as a problem of growing teams. So this is actually what I think a lot of software architects today optimize for, having a lot of people. And that's interesting, because why do we need a lot of people? So historically, we have been needing a lot of people because coding is very time inefficient. So it will take time to solve simple problems with code. And how have we mitigated that? Well, we try to parallelize. So we introduce many developers working in parallel with slightly different problems. And now we have an issue of they stepping on each other's toes and slowing themselves down. So this is the main concern, that if we need many people, then we probably should allow many places for those people to work. And then we might think that microservices are these many places where we can put developers to work, and they can forget about the world and just focus on their own thing.
Grows with the team. There's poor enforcement of modularity, right? To the extent that there's modularity within the monolith, it's because we've had discipline around it, as opposed to, you know, being essentially forced through barriers to be modular.
So poor enforcement of modularity. This is again back to issues with code, because if the code gets entangled and there's lots of stuff no one really understands, and if I don't fully understand something in a big code base, I usually introduce something that I do understand, and all of a sudden there's one more thing, and the next guy doesn't understand what I did, so he introduces a thing that he understands, but then he forgets about it and he introduces a new thing, and this explosion of crap brings any good software down. So that's why we focus on having rules of engagement when coding. You must try to understand these things prior to doing anything. You can't introduce new things before talking to us as a team, etc., etc. And all of these problems are endemic to coding. And why are they endemic to coding? The main issue that causes this is that code is hard to read. Hard to read, hard to understand. And since it is, you won't understand everything initially. And if you don't understand but are in a hurry, you do something haphazard instead.
There's very little opportunity for us to do horizontal scaling at this point. And then it's also, again, by definition, the monolith is a sort of single point of failure and a single performance bottleneck. So what you'll notice is that these cons are all things that happen at scale. And again, we're in that starting phase, so we don't really have any of these problems yet. So it's a pretty good bet for us to stick with a monolith in the early days. So other things that I think are appropriate at this scale of architecture include really prioritizing buying stuff and taking from other people's software rather than building it ourselves. So we want to make sure that we're spending that we're prioritizing leveraging a bunch of cloud infrastructure, which of course would be a lot faster, a lot cheaper, a lot better than we've been able to do ourselves. And then the companies that are like this, Stitch Fix and WeWork in my example, have no physical compute infrastructure anywhere in the world, so just completely in the cloud.
Yeah. So buy or rent, that's what you would do with the MDriven all the way, that you get access to the server components that you need to deliver the solution that you need. And you won't spend any time on except for setting it up maybe, and maybe you set it up in AVS or Azure or on your own server park. That's up to you. But once you have those things, you can focus on the internals of the system, the business problem, the solution that you are there to actually deliver.
The other thing that I think is really important here is spending a lot of time on detailed logging and instrumentation. So particularly in this phase where we're rapidly iterating, we want to make sure that we understand our user behavior really deeply, and that allows us to understand what problems the users are facing and what solutions we might be able to offer them. And then obviously also from a just kind of like operational perspective, enabling a better diagnosis and better recovery when we have more.
So this is something that's built into MDriven that you easily can turn on. You just import a model section, a merge model that handles logging of navigation and what actions users actually push. So then you will have a complete log that you can use for analysis on which views are used by whom, how often, and how are they performing.
More logging and instrumentation. So the other thing that I think it's really important to prioritize at this stage is making sure that we're able to iterate rapidly and update the software quickly. So.
And this is where MDriven shines. There's a one-button deployment, and it does everything from evolving the database script to uploading the model to the servers so that everything runs. And it's usually a 5-minute job, and then you're done, and you can continue developing.
So again, we want to make investments in continuous delivery. So that would be, making sure that we invest in a repeatable deployment pipeline where we have a, low risk push button deployment that tells us whether it's safe to move on. That allows us, even within this monolith, to have like a rapid release cadence, allows us to rapidly roll forward, rapidly roll back, and rapidly recover. It also ends up giving us a much more solid systems. It allows us to release smaller units of work, as we learned about in the keynote this morning. It gives, and if we have smaller, it allows us to have smaller changes that we roll back and roll forward, which gives us the ability to like repair things more quickly, understand things more clearly when we make changes, and then it's simpler to diagnose when something goes wrong. The last idea that I would want to add here is feature flag. So as we all know, it's the capability of adding a configuration flag to enable or disable a feature for a particular set of users. And it's been around for many, many years, of course. Now we can buy them as third-party services, which is great. And again, it's another tool in our toolbox to have us.
Okay. Just a reflection. Feature flags, of course, you have some singleton class where you set or maybe settings per user on what they should be able to reach. And that's, of course, just part of your information model. But as Randy said here, now you can even buy them as third-party services. Just because something is available to buy doesn't mean it's good. It's highly unlikely that you will gain from involving a third party in this part of your solution. After all, we are talking about something that's really simple. It's like in its simplest form, a Boolean attribute on your user object, which is checked or not checked. And that Boolean attribute should be checked in some enable expression for actions that are touching this subject, and then you're done. And just doing it like that is much less error prone than trying to import a third-party software library to handle the very same fact.
Develop more solid systems, so we can decouple code delivery from feature delivery. We can rapidly turn things on and off for either business reasons or operational reasons, et cetera. And it allows us to develop and test and verify our system in production. And then the last thing, obviously, that's really important for this is that, particularly again, as we're doing all this iteration, is we want to do experimentation, again, as we heard in the keynote this morning. And so it's important. So the ability to show things to some users and not other users allows us to experiment in a statistically valid way. And why is that so important? Well, I wonder if people have heard this statistic. So Ronnie Kohavi, who used to run experimentation at Microsoft and at Amazon, and I think now he's at Airbnb, learned this. So it turns out that at Microsoft, they looked at the features that they produced and were they good or neutral or poor. And it turns out that 1/3 of the features that they produced were in a positive direction and were statistically significantly positive. But 2/3 of the features that they produced were either flat, no difference, or they were statistically significant in the negative direction.
So, good. Interesting information. And as we start up, we won't have the volume of users to base any stats on them. So we will very much need to rely on our gut and how the users we actually do interact with react. So even if this is great to collect stats when you have a large body of users, you should definitely do that. And again, if you haven't invested that much to get a feature going, like you don't need to invest super much to get a new feature in an MDriven based system, that's good, because there's no way to know in which category your feature will end up. No one goes out and say, I'm going to do a negative statistically significant feature, of course. Everyone thinks that they are positive, but apparently 2/3 of them won't be. So it's important that it's easy and cheap to add them, and thus you don't have to cry when you remove them.
So this is a really sobering thought that we really need to make sure that we're even though we might think that the feature is particularly good that we want to release. I mean, obviously that's why we're doing it. But 2/3 of the time we're wrong about that. So we need to make sure that that we give ourselves the operational and software tools in order for us to experiment quickly and notice when things are good and continue to do more of those, and notice when things are flat or down and do less of those. Okay. So now let's move on to the next phase, which I'll call the scaling phase. So now, rather than one team, we're several teams, and we're growing and adding more teams. Now we have a longer time horizon, so it actually makes more sense for us to invest in longer-term approaches. But again, if I look
Yeah, let's hear him out.
overall at like the number of applications that are in this, in the world, like it's a pretty small percentage that are actually going to benefit from the
1% of all applications are in this phase when they sort of blow up when it comes to users. 1%. That means that 99% are sort of left in starting. And when you think about it, that sounds not unreasonable, because most systems have great hope, and they might be very highly appreciated and great used, but still, the delivery mechanism might not be the world or the web, or the open web. So if you think of SAP, which is fairly popular, they don't have hundreds of millions of users in one instance of their system, because there are no companies that big. So depending on how you segment your delivery, are you going to do a new instance of your system for each customer? Okay, then maybe you will never get to scale. And also the thing that is said about multiple teams as you scale, that's also something that you need to challenge. Is it necessarily so that you need many teams, many developers, just because you have many clients? And traditionally it has been so, but that's because code is labor intensive. If you can move away from code and move back to idea space, which is modeling, that's much less labor intensive and much less, like a lot. So it's not necessarily so that you will have 15 teams working on one model, just because you will have 15 teams working on the similar solution written by code.
Things that we're going to talk about going forward. So maybe the first question is, what are the warning signs when we're running out of gas in the monolith? So the first one that I've seen in my personal experience is what I'll call feature velocity, like our ability to rapidly release.
This is super interesting, because here he actually points out that the main problem with the system development as the system grows is not so much, it might be, but he doesn't bring that up here. It's not actually the technical aspects on the load of traffic, etc., of data. It's velocity of the team. So what does that even mean? Well, you have a lot of developers and they don't really understand what they should do. And if they don't understand what they should do, they need to talk to each other a lot to understand what has already been done and where to fix a thing. And this is what you get when you're building with code, because it's getting more and more entangled by the day. It's harder to find, and it will get slower and slower very quickly. This is a logarithmic curve. You can't really hope to work on a system for more than 5 years before it's at least half of the developers involved will silently say, we should really do a rewrite. We should start over, because no one can find anything here.
These new features sort of ends up slowing down and ossifying. And so our time to market is slowing down. Teams are stepping on each other's toes because they're in the monolith and they're no longer able to develop independently.
So this is totally different using models, because we can work on the same model for tens of years, and we don't see really any slowdown. But why don't we see any slowdown? It's not entangled. It's just clearly named things that all live in the same space. Just like you don't get bogged down by learning more words. It's okay. You evolve your ability to express yourself the more words you know. That's not the case when using code. When using code, a considerable effort goes into knowing how the system works internally in your head, because there's no way to quickly read it from the code or looking at the maps of the system, because that's never enough. Looking at the model is usually enough. So the slowdown doesn't exist in MDriven.
And then the other kind of related warning sign is that when we're bringing new engineers onto the team, is it difficult for them to be productive, right? Like if they're able to show up and be productive pretty quickly, okay, we have a great modular system. If they have to understand a lot of interdependencies and you know, a big ball of mud, like that's an issue, and we need to make sure that we deal with it. The other reason that I've often seen in terms of re-architecture is simply scaling, right? So when the vertical scaling of the monolith runs out of gas and it no longer gives us enough to continue to keep up with our rapidly growing site, and parts of the system need to scale faster than other parts of the system.
Yeah, so this is the other part that actually is valid to re-engineer for. I don't think velocity should be an issue, because velocity problems are actually an indication that you don't understand what you have. And splitting the thing that you don't understand into multiple parts will only solve the problem a very short while, because you won't understand those parts either after a little time. So scaling, when it's come to traffic and data and things getting too choked, that's fair, and that's when we need to think, what is it that cause these problems? Here I think it's important that we don't always think that we should solve it by changing the routing of information on the servers. Quite often solvable by doing things a bit differently, by introducing some kind of new domain-specific bucket for the information, so you can chunk it into different types of problems and not having all one big problem, making it slow to handle that particular big problem.
And then the last thing, which is rarely alone, but is usually in combination with either or both of the velocity point or the scaling point, is that parts of the system want to be deployed independently, right? So the monolithic release is too slow because it bundles everything up together. It's too complicated or it's too risky.
Yeah, so this might be an issue, but again, I can't really see how a model-driven deployment would get super complicated. This is, again, an endemic problem to being too techy. So, if I update this, we need a new version of this server component, but that's not compatible with this other thing, etc., etc. And it's just the wrong level of solving business problems that have gotten you to this situation in the first place.
And so, we might ask ourselves, like, why are we redeploying the authentication system every time we update the JavaScript, right? Like, that would be pretty silly. Okay. So a lot of times people are like, well, why didn't we just build it right the first time? Right? Like, why didn't we just build scale in from the very beginning? And the way I like to think about it is getting to re-architect a system is a sign of our success rather than our failure, right? Like, why are we re-architecting? It's because people care and because the initial things that we did are no longer keeping up with, the usage and the growth and the scaling of the system. So again, I think re-architecture is a success measure, not a failure measure. Okay, now is the time when we're starting to build or leverage separated services, and usually it starts with money for a lot of reasons, right? So breaking out payment systems and so on like that. And then also we're going to be in a situation where we're going to start layering those services. And then very similar to the talk that we just heard about event-driven, about migrating to event-driven architecture, this is a time where we're going to start to introduce something like that, some kind of event queue or message broker or something like that allows us to use messages to communicate between the separate applications and services in our overall architecture. And then the other aspect here is we want to start introducing scalable persistence mechanisms. So we're going to talk about this in more detail in a moment, but like, to the extent that we have a monolithic database, we're going to be breaking it up or figure out how to do that. We're going to be functionally partitioning the database into parts that serve one part, one set of entities, and other part with serving another set of entities. And then sharding these things is an appropriate thing that starts to happen now. Okay.
Yeah. So how would you do this in MDriven? So it's basically an idea of breaking the model, drawing a line in the model where it is most depending on how the information looks and how your model has dependencies and associations between classes. There might be areas which have very weak dependencies between them, and then that's a good fit to split. But you should only split if both areas which you divide into actually has a lot of data, so that these are part of the problem that you're trying to solve. It's no need to split things up just for splitting. But if you can find a way to draw a line in your model to have 100 classes of information here and 100 classes of information there, and that halves the load on each database, that's good. Then of course you will have some reference problems between these, because there were associations between these two areas of that, I'm sure. And then you can have different strategies on how to share that reference data, and that's just some messages going back and forth between those system parts to keep them in sync, because probably you still want to have a representation of the data that you reference locally in both systems. So there will be copies of that data, and one of the system is allowed to write it and the other is only allowed to read it. And doing that is effectively what you have done after a successful split like that, is that you have introduced two microservices. You have split the monolith into two things. They are both the exact same technology as they were before, and they are both still model driven, but they are two parts. So and now you need to be a little bit wary when you deploy things, but because should you deploy only one or both? Well, it depends. Have you changed anything in the contract between the two, etc.? But this is actually not a hard thing once you know what kind of problem you're trying to solve.
So now we're in the microservices world, right? And so just super briefly, I want to make sure that we're all talking about the same thing. So to me, a microservice is a service that serves a single purpose. It's got a simple, well-defined interface, and the individual services are modular and independent. And then a critical aspect is
So I don't totally agree that it should serve a single purpose. The main idea by introducing microservices is to split load. It's not to make engineers having their own sandbox of code that only does one thing. That's not the driver for microservices. The driver for microservices is performance.
Is that those microservices own their own persistence, right? That they
So this is what I said, that each such microservices in turn is a monolith in every aspect. So a microservice delivery is just a farm of monoliths which are connected somehow.
So microservice architecture, has a bunch of cons. So now, even though each unit is simple, now we have multiple cooperating units. We've exchanged those in-process latencies for network latencies. Now we need to introduce much more sophisticated deployment and monitoring capabilities. And arguably, the overall system complexity, at least from a boxes and lines perspective, is higher in this microservice world than it was in a monolithic world. OK, doing it incrementally. So when you're in a situation as eBay was, back in that horrible V2 ISAP EDLL with a 3.4.
So, now in this section, he talks about migration. And migration happens for different reasons. And one of the particular migration here is that they have discovered that they need to introduce more granularity in their infrastructure, introducing microservices. And then they need to cut things and put a few things here and a few things there. And since the thing that they're going to cut is 100% code, it's not obvious how that is going to cut and if we will damage anything during the cutting. Now consider that you were in a model space instead, the idea space, where you have all the words in front of you, all the entities they're naming and what they mean, and hopefully you understand what they mean, and the associations between them. It's pretty easy to see. It's not super easy, and you still need to take care, but it's not hard to know where to cut. And everything where you cut will be like strongly typed, so you know if there's something missing in part A versus part B, if there's something left out. Because if part A still references things in part B, but it doesn't see it, we will get some errors here. So that's fine. That's just part of discovery. And I think migration is really hard if all you have is code, because the understanding of what you are migrating is in code. It's not anywhere else. So if you end up needing to rewrite a few things, that actually means that you need to re-implement a lot of business rules. And you don't have anywhere where you can trust that those business rules are defined. You had a place that was an Excel sheet where the requirement was a year back. But you know that you made changes to that later on. The business came back and said, well, that wouldn't work. We need it this way instead. You've done those changes throughout. Maybe not you, maybe someone else. You don't know. And you see this code, and maybe it encompasses all those changes, maybe not. Maybe there are still open bugs on this. But still, you need to try to isolate this part and then reinvent it somewhere else. Hopefully, it's the same language and target environment, even if Randy Shoup said that possibly you could change technology when you're doing a new microservices. In that case, you also need to reformulate the thing in a new language. And this is really error-prone and expensive And the business value from a non-functional or from a functional perspective is 0, right? A non-functional requirement is that, well, now things will go faster once we're done. That's a non-functional requirement. That's good, and the business will want that. But you can't say to the business that, well, it's hard to read code. Well, yeah, I don't care. So why did you do code?
4 million lines of code. You want the first step, or the step 0, as I like to say, before we do one of these, as we do one of these migrations, is pilot out building something in the new system so that we can figure out whether in other parts of the company. So we're kind of, are in the sort of optimizing.
So I'm going to break off here because now is moving back to optimizing in reducing both number of teams and probably also number of microservices depending on reduced load or that we discovered that some weren't needed, etc. So in order to focus to minimize maintenance cost, and of course that's a really, really important aspect, because most of the money spent on a system is actually spent after initial development, and that's the maintenance. And if we can reduce teams so that fewer people can manage this, that's good. That's often hard when you have code, because then well, if the code is working really well, fine. But if you still want to be able to change, to add features, you need to understand the code really well. And that might be hard. It's much easier if you were in an idea space all the time and you have a complete model describing your complete system. And it's very easy to add or remove things from there. So, summing it up, I think this was a good overview of the state of things, and I applaud Randy Shoup on the way to do things with code. But the only thing that I have an alternate interpretation of how to do things is that you should avoid code for the business content of the application. It's not really the best vehicle to maintain detailed business information. Thank you for listening.